Okay, this is a continuation of the notes for section 9.3 in Algebra 2. And what I'm going to do on this is, first of all, find what are called points of discontinuity, and then distinguish between two different outcomes that you get when you have a point of discontinuity. Now, I'm just going to kind of tip my hand here. A point of discontinuity is a place where it's undefined because q is equal to 0. And remember, it's undefined when that happens. So your graph stops. It just doesn't have any value at that location. The x value is creates a y value that's undefined. And that'll result in one of two things happening. These points of discontinuity are either an indication of a vertical asymptote, remember you say asim and the p is silent, and then you go tote, asymptote, or a hole. The goal on this page is to help you figure out which is which. So first you're going to find out all of the points of discontinuity, which are both types together. And the possibility that causes a break, it's called, these are called and this will cause one of these two types of breaks, a vertical asymptote or a hole. In the case of a hole, the x value causes both the top function and the bottom function to zero out. Look for a binomial factor that cancels out in both the top and the bottom. In the case of a vertical asymptote, it's only the q of x that equals 0, not both of them. So in passing here, we saw that we should factor the top and the bottom. The top is called p of x, and the bottom is called q of x, and you want them in factored form. Now, this first example is already done for us. You can tell the bottom's factored. It's got this first factor of x plus 2 and the other one of x minus 5. Now, if I set that bottom equal to 0, I'll find the points of discontinuity. X equals -2 and x equals 5. You've done this for a while in a different context. These are called points of discontinuity. And now I have to distinguish which is which. Now the graph over here kind of gives it away. At x equals -2, we get a vertical asymptote. And at x equals 5, we get this hole. So I'm going to show you how to tell on this function here which is which. If you plug -2 in, the top is -7. And it does not zero out. But the bottom does. If you plug -2 in, you get -7 there and 0 here, and 0 times -7 is 0. So this is a vertical asymptote since only the bottom zeroes out. But when you put this 5 in, the top zeroes out and the bottom zeroes out, and that's how you tell it's a hole. Now, if you want to think of it as canceling off here, that's also an indication that there was a hole at that location. All right, the next one here is 2x plus 3 over x squared minus 10x plus 24. The top is ready to go, but the bottom, we have to factor this. So I'm going to use the star method. I'll put a 1 on both wings, and 1 times 24 is 24. The middle one is -10, and I'm looking for numbers that multiply to give that one and add to give this one. There you go. -6 times -4 multiplies to give 24 and adds to give -10. And now if you can simplify these fractions, you have to do it, but these don't. So we get the following version. of the bottom. Oops, that's supposed to be a 3. And on the bottom we get 1x minus 6 here. And over there 1x minus 4. Now if you set the bottom equal to 0, you're going to get 2 points of discontinuity. X equals 6 and x equals 4. And if you plug 6 in, you 0 at the bottom. You can picture 6 minus 6 there with 0 at the bottom. Putting 6 in up there does not. So that's a vertical asymptote, and you can see it right here at x equals 6 on the graph. There's another point of discontinuity over here, and if you plug 4 in, the bottom cancels out and gives 0 because 4 minus 4 gives 0. But the top does not give 0, so that's also a vertical asymptote. And you can see it right there at x equals 4. So we had 2 vertical asymptotes on this one, and there is a horizontal asymptote coming through there, and we'll deal with that later. Okay, let's find the points of discontinuity on this one. The top factors as x plus 2 and x minus 2. Maybe you recognize that's a difference of squares problem up there. And the bottom, I'm going to go ahead and do the little star off to the side here. You put this leading coefficient of 2 on the sides. 2 times negative 6 is negative 12, and the middle number is 1. I need 2 numbers that multiply to give this and add to give this. I'm going to go with 4 and negative 3. Now this side simplifies. So that fraction indicates this factor, x plus 2. And the other is 2x minus 3. So first we're going to find the points of discontinuity. X equals negative 2 and x equals 3/2. Plugging negative 2 in would 0 this out and this out, so that's a hole. And you can see it right there. Negative 2 for the x. I'll show you later how to find the height, where to plot that. And then this 3/2 would 0 out this factor, but neither of these, so that's a horizontal or a vertical asymptote, vertical asymptote. And you can see it right there. So if you want to graph this, you can hit trace negative 2 and it would 0, you'd see nothing there, and trace 1.5 and you'd see nothing on the y on that location. Now to find this height here, you just move over a tiny bit, maybe negative 1.99 or maybe negative 2.01. So that's what you would trace to find the height of that hole. And there's a vertical asymptote cutting right through here at y equals 0.5 is where it is. And later I'm going to show you how to find that horizontal asymptote. Its location, that's part of the notes also. So we'll pick up on page 3, and I'll see you on the other side.